When you look up at the night sky, it's easy to assume you're staring into a vast, empty void, just a dark, silent stage. But honestly, that's a total illusion. Today, we're diving into a fascinating mystery of the observable universe, why space is mostly invisible, and how our physical world is defined entirely by what we can actually detect. So why does space look so empty? Well, it's tempting to think darkness just means there's absolutely nothing there. But the universe isn't some giant vacuum of nothingness. The reality is, our ability to perceive what's out there is strictly limited by the physical boundaries of light, immense distances, and the limits of our own instruments. Here's the crucial point. The universe is only visible where information can physically reach us. This takes a massive shift in how we think. Seeing doesn't equal reality. Seeing just means receiving a physical signal, a faint glimmer that somehow survived a perilous journey across the cosmos. To picture this, imagine trying to understand a bustling city at night from a distant hill with just a single, weak flashlight. Your beam only reveals a tiny patch of one building. If thick fog rolls in and entire neighborhoods are miles beyond your reach, that city feels completely empty to you, even though it's teeming with life. To truly grasp this, we've got to redefine what light actually is. Light isn't just brightness, it's the ultimate cosmic messenger. It's a traveling envoy, carrying vital encoded clues. It holds the secrets to a distant star's temperature, its chemical makeup, and its breakneck speed through the void. What's really wild is that this cosmic messenger travels with two distinct faces. On one hand, light behaves as a continuous wave, spreading out through space like repeating ripples in a pond. But at the exact same time, it arrives as discrete packets of energy, kind of like individual droplets falling from a showerhead.
This brings us to a huge misunderstanding. We usually think objects possess a fixed color, right? But color is actually an interaction between the source, the emitted light, and the detector receiving it. A massive star might be screamingly bright in X-rays, but completely invisible to our human eyes. We miss the whole story without the right kind of light.
Observation is not just a simple camera snap. It's a precarious gauntlet, an incredibly fragile chain of physical events. First, a source emits a signal. Second, that signal travels across space. Third, a detector takes it in. And finally, a mind interprets it. If we fail at any single link, that object is entirely unobservable. Because of this fragile chain, we have to accept a tough reality. The signal is not the thing itself. We never capture the physical star, we only hold its muffled, filtered record. It's like trying to enjoy a symphony orchestra from the alley outside. You don't get the instruments, you only get the sound waves that vibrated through heavy brick walls. Think of the cosmos as a massive observation funnel, where at literally every stage, precious information is lost. The source might emit undetectable light. As it travels, the signal gets weakened by sheer distance or absorbed by dust. Then our detectors might not be tuned to the right frequency. By the time it reaches us, it's like reading a profound letter that was photocopied, smudged, and carried through a rainstorm. Waiting at the bottom of this funnel are our telescopes. But detectors are not magic eyes. They're physical nets cast into the cosmic ocean. And a net only catches specific sizes of fish. Perfectly real structures exist out there right now, but go completely unobserved simply because our instruments aren't built to catch their specific signals. Even if a faint signal does reach our net, it faces a relentless enemy: noise. Unwanted background fluctuations are constantly fighting to drown out the true signal. These weak messages enter a desperate fight for survival against the chaotic radiation of the universe. Isolating that signal is exactly like trying to hear a whisper across a roaring, crowded cafe.
Which brings us to the dual challenge of our detectors: sensitivity versus resolution. It's one thing to have the sensitivity to register a faint blur of energy, but it's entirely different to have the resolution to actually distinguish that distinct cosmic structure before it blends into its surroundings. A signal might survive the entire trip, but arrive too blurred to ever decode.
This realization brings us to a profound truth. Vast portions of reality are permanently invisible to us, but absolutely not because they're absent. They're invisible because their signals simply cannot survive the journey to beat the noise. Darkness doesn't mean absence. Darkness is just what remains after the signal has been reduced below the level of usable light.
And that leaves us with a wondrous realization. The edge of visibility is where physical data ends and human inference begins. Our knowledge of the cosmos is rigidly bounded by the fragile geometry of traveling information. Massive cataclysmic events are happening out there right now, permanently cut off from us simply because their messenger will never arrive.
So the next time you look up at the night sky, remember this. Darkness often means undetectable, not non-existent. The vast blackness of space is not some mysterious empty void. It is a highly structured, hidden reality waiting for a messenger that can survive the trip. What else do you think is out there quietly existing just beyond our fragile cosmic nets?